Go ahead and flip the recording so we will have a nice clean one for the YouTubes. Welcome everybody to Handmade Hero, the live show where we code a complete professional quality game from scratch using absolutely nothing, no libraries, no nothing, so that we can basically see how every little part of a game works. And I've said it multiple times, I'll say it again, I think it's absolutely crucial for a good programmer's education to kind of go in and just see how everything works and really understand it before you start to do things like using higher level stuff or using libraries and stuff like that. And there's just not a lot of material out there that kind of shows how to do every last little thing so that you can kind of fill in those gaps sort of as you go and become a better game programmer. And so what we're basically trying to do on this stream is build a game where we build absolutely everything. And so far it's been going pretty well. We've basically gotten through the Win32 interface portion of things. We're at the point where we're playing sounds and showing bitmap stuff on the screen and abstracting both keyboard and gamepad input. So we're pretty close to being at the point where we're going to start actually just working on the game part of the game, which is not too bad considering the fact that it has been, I guess, let's see, 17 hours, which is not a lot of hours. We only do 1 hour a day. So that is not very much to consider how far we have come. And so I'm pretty happy with our progress, and I hope you are too. Today, our primary goal is to sort of finish cleaning up the Win32 input stuff, just get that nailed down so we can kind of move on and forget about it, and also maybe start to take a look at timing in the game loop, which is one more thing that we've kind of got sticking around that needs to be cleaned up. So I'm going to go ahead and jump in here. Obviously, for those of you who have pre-ordered the game, you have access to the full source code with the link that you got in your email. If you download that, every night it gets updated, so you should have a zip. If you look at what day we're on 17, you should have a zip that has all the day's source codes in it. So you want to unzip day 16, because that is what I'm starting with here on day 17. We always start with the previous day's source code, so if you want to follow along at home, unzip that day 16, and you will be exactly the same place that I am right now when I open this up. So, where we left off, let's just talk about that for a minute. Basically what I'd done is inside WinMain, which is our entry point, I had gone and said, well, I want to add keyboard input here, and I just kind of quickly did a few things to get us in position to finish it up today. Basically what I did is I said, well, inside our WinMain we had a message loop where we basically processed our messages from Windows. And I moved that out into its own function here. It's called Win32 process pending messages. And basically what I do is every time through here, we ask Windows if there are any messages to process, and as long as there are in our while loop, we will process those messages. Now, I didn't want to actually use our window handler, our Windows callback function, basically for our window. I didn't want to use that to process the keyboard input because I was pointing out a very important thing about flow control. Basically, when Windows does its callback, we have no control over what gets passed to that function. This was our window callback function here. Now we need to have this window callback function because sometimes Windows calls our window function with stuff directly, like the WM Paint message will sometimes come in just completely out of the blue. It won't go through our message processing loop. Windows knows because we registered, I don't know if you remember this, way back from like the first or second day, I guess, second day probably. Windows forced us to register a thing called a window class, which talks about the window, the kind of window we're making, and in that we gave it a callback, and it is actually free to call that callback anytime it wants to. So we pretty much have to make sure that we handle some set of Windows messages in here that can be dispatched at any time. However, keyboard messages do not seem to ever be dispatched out of line like that. They always go through the actual proper message loop with our peak message and so on. So if we want to, we can process the messages right here and just never bother to have Windows dispatch them. Because normally what would happen when it's not sending out a band like that is Windows sends us the message first in this loop. It allows us to pull that message off the queue, and then it lets us tell Windows, okay, now it's time to dispatch it to the Windows routine, okay, to our window handling routine. So it's kind of a little bizarre. It's like we pull it off, we look at it, we then tell it to dispatch. That would actually be a nice way to go if it weren't for the fact that Windows can sometimes just sneak in a call directly to our window. So we have to have the window proc. There's nothing we can do about that, but what we can do is for all the messages that don't get spontaneously sent like that, we can choose to process them in here. And that's really nice because what it means is we can actually just have this still be in our standard control flow. We can control what gets passed to it, so it's nice and clean. It could be more functional. And of course, what I mean by functional, we haven't really talked about that on the stream. But it's something that's worth noting, so I'll mention it here, and I'll mention it again a couple times because it's something worth understanding. When you're doing coding, there's kind of two general ways you can think about a given function, even though there always are functions in programs. If I have a function, and I will call this functional function, let's say. This is a functional function. And then I have something which is a procedural function, or whatever you want to call it. Function with side effects, let's say. Function with side effects, because side effects are typically what distinguish something functional from something not. What distinguishes two sets of functions is whether or not, into functional or non-functional when we use that term. Basically, a functional function is one which does not modify anything other than the stuff that it is passed and that it returns. So basically, it is going to get some values which are not pointers to things. They're not references to stuff like graphs that can be crawled or any of this sort of stuff. They are actually getting in values which themselves are not sort of writable memory. And then it returns something that is the result of whatever it's going to do. So, maybe it's going to do this sort of thing, right? And I am going to return that, okay? So this is an example of a functional function. It takes two things which it does not use to go modify other stuff. It returns integer, never touches any global variables. So basically, it is entirely, it is functional almost in the mathematical sense that you would think of a function in math, where it takes parameters in and it outputs a result, but nothing else changes. The state of the program does not change in any way other than the fact that this result was computed. That's it. Now, when you have something called side effects in a function, it ceases to be functional. And basically what that means is if, let's say, I did something like this, and then I had something like foo star foo, and here's my foo, right? It's got some stuff in it. Maybe it's got a pointer to a bar, and it's got an int in it, and it's got a result, and all sorts of things. And in here, I just go, all right, and maybe I still pass the y. So, I'm going to go ahead and take the foo arrow result equals the x plus y and so on. Or I might even do something where I look at the bar and I find out, if the bar z is equal to 5, I'm going to do something, right? This is more typical of C-style stuff. And basically what ends up happening, right, is you can see very quickly that the understandability of this function becomes much quicker, much more complex when I have sort of things that fall out of, that diverge from that functional style. When I'm not just taking some simple parameters in and having a simple return value come out, I start to have a lot of more complexity into what might happen when you call this function, right? Like maybe this function is going to write to foo result, maybe it's only going to write to foo result under some circumstances, so on and so forth. And basically what I've produced is something that, in order to understand what happens when you call this function, you have to actually understand the structure of the data of the program and how it exists in memory. You can't just look at it trivially and go, oh, I see. I pass it two things and back comes the result. That's all that's going to, there's nothing's going to change in the state of my program. The state of my program is effectively immutable to this functional function. The program state is identical to when I called it. The only difference is I got back a result that I can now use to do something. Whereas in this one, the state of the actual data state of the program has been mutated by the act of calling the function. And that's kind of what we mean when we say side effects. It's calling the function changes the permanent data store in the program in a way that means that if you called it, say, twice in a row, or if you inserted a call to it between two other calls, those calls themselves could also be changed how they operate, right? Two functions with side effects getting called in opposite orders, for example, might have a different effect, whereas two functional functions called in opposite orders can't, because they don't change anything. So if I call one functional function and another functional function, I know that I could swap the order of those calls, for example, and nothing would change because the only state that they're getting is what's passed in the parameters. So unless I took the result of one and passed it to the other one, I know that they have no connection to each other whatsoever. And so there's just a lot of things that happen when you can boil something down to a functional function. And there are programming languages that are all about being almost entirely functional. For example, things like ML, for example, are programming languages based around this concept. It's a very limiting way to program because there are so many options. There are so many things the CPU can do that are off the table now for you. But if you are in a situation where you can make things more functional without sacrificing something, it is often beneficial to do so because it makes the understandability of the program and the reliability of the program increase in most circumstances, because now there isn't this knowledge of the state of the program that has to be going through the programmer's mind when they do things in order to make the program work properly. They can literally just see a function, know that when they call it, it does the same thing no matter where in the program you are. They don't have to worry about setting something up, shutting something down, all these sorts of things. And so what I typically try to do when I am programming is I do try to push towards functional when it is not prohibitive to do so. So what does that mean? It means passing things as parameters rather than using global state. It means passing things by value rather than by reference if possible, and making them so that they're not going to be changed by the function. It means limiting the access of functions to only the things that they absolutely need to use, so that they're easier to understand. And I never really ever get to a point where my code is super functional. That never really happens. It's not the nature of the kind of code I tend to write. But I do try to follow those steps to sort of increase the functionalness of the program, because every little bit you do is a bug down the line, a readability plus down the line that didn't happen, whatever, that sort of thing, a complexity down the line that you didn't have to deal with. And so what I like to do here is basically there's a more complex program flow thing that would happen the way that we used to do things. In our old Win32 window handler, sorry, having trouble finding it there. In our Win32 main window callback, if this were processing the keyboard messages here, right? If this were processing those keyboard messages, it would have to have a place to put them, right? It needs to store the result of those keyboard operations. And in order to do that, that means it would have to have access to the input structure. But as you can see, I can't pass that in here. I can't give it the thing that it's supposed to be operating on because Windows has defined the function prototype for this call, and there's nothing I can do to insert myself in here. So in order to basically do the plumbing necessary to get the keyboard, basically the place where the keyboard result should be written into this function would require a global variable using the local storage in the window itself, using Windows to get inside a property, for example. I would have to use something that is very much not functional at all, because it would basically be something where the state was completely implicit and you just had to know, oh hey, by the way, the main window callback just magically knows what controller to write to and it got it from this global variable and hey, don't worry about it, right? And I don't like having things like that. So I can do much better by pulling it out into a function that's under my control. Because while again, it's not going to be functional at all because it's using a message queue and pulling messages off a queue, so there's nothing functional about this function for the most part. But I can make it into more of a stable functional flow control where I'm still passing the output place directly in, and it's understandable, very clearly understandable in that functional way. It's much more easy to understand for the programmer what's happening. By saying, when I do Win32 process messages, I just pass it directly where I want the stuff to go, and that allows me to use this function anywhere I want to basically say, here's where I want you to put the stuff. And anyone else could use that to put stuff in a different place if they wanted to, and anyone who calls it knows exactly where the results are going. They're not in this state where they're like, I don't know, I had to set a global variable first, and then it figured it out, and so on. So, something to think about. Something to think about. People were saying on this, I just glanced at the chat just then, they were saying I was a little too loud. We could easily turn the, oh, you know what? I think this was not... oh wait, no, that's the microphone. I think we could set the microphone down a bit though. I'll do a quick mic check. Is that better? Is that less clippy when I'm talking? What do you guys think about that? This is an example of me talking as loud as I talk. So there, you can tell me in the stream and I'll glance back at it to see if maybe that's a little bit better, if that's less clippy for people on stream. Let me know if that's better, if it's harder to hear me. All right, there we go. All right, so now that you understand why I did that, what I do need to do now is actually finish the actual keyboard processing, because we didn't actually do hardly any of it. We didn't actually do the work of getting things into a good state for using the keyboard. So the first thing I want to do is I want to kind of look through here and kind of clean up the way that we're thinking about input, because it wasn't set up particularly well in the first place. So the first thing I want to do is I want to say, all right, let's just for now, because like we said, when we get down the line later and the game is more complete, we will kind of revisit how we're doing input and how we map things and all sorts of stuff like that. But for now, what I'd like to do is say, let's give the game basically, let's have the keyboard come in as one controller. Like it's like a gamepad, right? The keyboard comes in as a certain controller. It's controller 0, let's say. And then the first gamepad is controller 1, and the second gamepad is controller 2. Let's make it look like that. I think that'll be a sane way to do it to start, and then later we'll kind of get into things maybe where we want to do something a little more complicated than that as we see what our game actually wants. But I'm going to go in here and basically say, oh, and the other thing I should probably do is put this in there, I guess, to make sure I don't put anything down in the corner. I always forget to put my little blocker up, so I remember not to put any code in the corner. So let's go in here and just take a look at how we're storing things. Basically, we've got 4 controllers mapped in here, but what I'd rather do is up it to 5. So I'll have 4 gamepads and the keyboard is basically how we'll do it. And so the keyboard controller will be controller 0, but then when we kind of go in here and use these controllers, instead we're going to actually say, all right, let's make this be controller, this is X input, basically our controller index is mapped differently. So we'll say our controller index, right, is going to be the controller index plus 1, because we're basically leaving space for that keyboard controller. So now there are actually 5 controllers in here, not 4. So when we go in here, we will basically have to modify our check for how many controllers we actually think is the maximum. So basically what we need to do is we need to say 1 for the keyboard plus the X user max count, and then we'll just double check that that all fits, and then off we go. So that's actually what I wanted to do. Oops, I spelled it. That's good spelling. Off to a good start with our spelling today. Can't even spell. So that's good. Oh, and this is something that I think I forgot to do yesterday. You'll notice we have a link warning here. So basically, I showed yesterday, and I think some people missed it because the stream dropped out, and so if you didn't watch the YouTube, you missed it. I showed basically here how to, on the 32-bit build, how to get it working on Windows XP. But you can't actually use Windows XP builds if you are doing 64-bit, because 64-bit builds with the 64-bit compiler don't run on the Windows 5.1 XP thing as far as I know. So basically what you want to do is we actually want to have sort of a 32-bit build line and a 64-bit build line. And in the future, what we're going to want to do is actually build both potentially. But like I said, I couldn't do that yesterday because I have to go do a bunch of stuff, extracting stuff from VC-vars to call the right compiler directly, since you can't use the same compiler to build both and all these other sorts of things. But basically what we want to do is say, well, there's going to be 2 build types, right? There's going to be one that's for Win64 and one that's for Win32, so we could do them like that. But what I'd like to do is most of the stuff is shared between the 2 of them. So what I'd like to do is I'd like to just take a second and say, let's set a variable here that's basically like, for now, we'll call it common flags, and we'll do some more work with this in the future. But let's just say, you know, okay, we basically want all of this stuff for now to be in our common flags. All of this stuff kind of comes in here, right? That's our common compiler flags, let's say. And then we'll do common linker flags that are just the things that we actually wanted to pass to the 2 different parts. So we'll grab that there, put that up there, and say, okay, that's common linker flags. And basically all I'm going to do is say, all right, so this subsystem piece, we'll take that out of the common and we'll stick it in only the 32-bit version, right? And then this one here will just be basically the same as that, only it won't have that one piece. And so then that'll let us do either of them, I believe. Oops, it's not right. I'm missing that. Is that right? There we go. So basically all I did here is just made 2 lines, one for the 32-bit build. So basically we've got the 32-bit build here, and basically we've got the 64-bit build here, and they're going to be exactly the same, except for those things. We might change some things. And in the future, we'll make another variable here for release flags as well, so when we want to turn on optimizations, we can do that. But let's just do that and get that out of the way. All right. So now we've got our controller as well. I'm going to go ahead and make sure that we didn't mess anything up there because I kind of was talking about a ton of things there and hard for me to pay close attention to what's going on. So I like to run the game periodically to make sure I didn't do anything horribly bad. All right. So now that we have this, we need to actually process our keyboard controller for real. And so what we need to do is when we actually take the new state of the keyboard controller, what we probably want to do is say that it should actually, if we look here, the way that I've got it, we basically want to preserve some of the state. We've got the ended down thing, and we have to make sure that the ended down, we have to make sure that if we don't receive any keyboard messages this frame, we are still accurately representing the state of the keyboard, which is not something we're actually doing at the moment. We always zero out the state of the controller. So if a key goes down, we'll receive a message, we'll set ended down to be correct, that we implemented. But what we didn't do is actually make sure that it would then persist to the next frame so it would still appear to be down. And so that's what we have to actually handle now. So what we want to do probably here is basically we only really want to reset the half transition count. We want to leave ended down basically the same. So what we can do that two different ways. I guess what I'll do is I'll clear the keyboard out for now, and I will just loop over these buttons real quick here. I'll basically say that the button index for the keyboard, I'm going to go over the array count of keyboard controller buttons, and from there I will basically take each one of those things and I will basically map sort of the old one to the new one. So I've got the old input. And I've got old keyboard controller, new keyboard controller, and basically what I'll do is I'll zero the new one. You can see what I did here was just make a blank one and assign it to do a clear. And you see I did a zeroing macro to do, which maybe we'll do today during the cleanup if we've got time. Basically, I'm going to come in through here. I'm going to take the old keyboard controller, and I'm going to grab its buttons here. So I'm going to get its buttons, pull out the button in question, and I am going to make its ended down equal to, so I'm going to make the new one, I should say, equal to the old one. So this basically just copies whether or not the key was down to the new one. So that way we know that when we come in here, our new keyboard controller has the same ended down state, but we now know that the half transition count is clear, which is what we want, because we're supposed to count half transitions per frame. So when I come up here into the processing loop and I look at what I'm calling the Win32 process keyboard message. Basically what happens is anytime I get the message, I increment that half transition count, and then I set the ended down to the correct thing. So this basically just counts how many times we changed it. I can also assert here that basically the new state ended down is not equal to the new is down type. Because remember, we're only supposed to be getting this keyboard message if the state changed, because we very explicitly check for it right here. We basically say we're not going to process the keyboard event if it was just saying that a key was down that was already down. So that's a key repeat message, and we don't want to be a slave to Windows key repeat settings or do any stuff like that. We want to take that out of the equation entirely. So basically we just want to assert that we didn't do something stupid, because oftentimes in programming you will do something stupid because you forget what's going on or you make a change and don't realize what's happening. So we want to assert here and just say, hey look, we want to make sure that when we get an is down message, it's actually a difference. It's either, if it's true that it's down, then the key shouldn't already be marked as down, because our half transition count would be wrong at that point. And we also want to check for the opposite. If the key is saying that it's going up, we want to make sure that it wasn't already up. So now when I do that and fix the bugs here, the typos, and there we go. Basically all I need to do is verify that that worked at all. We'll go in here, and there you go. So that's me pressing the button just like I would have on the controller, and hey, it works perfectly. Now we need to process the directional stick, and that brings up something that I've been wanting to do for a while, which is we actually need to kind of finish all of our directional stick stuff, because our Gamepad directional stick stuff still had a to-do in it as well, which is basically that we had a dead zone processing to do, where we didn't process the dead zone because we didn't really talk much about what the dead zone was. Now, the dead zone is basically, it is not a game about zombies, although with the way the game industry is going these days, it will probably soon be a game about zombies. Somebody out there right now is maybe taking the Handmade Hero platform layer and is turning it into a game about zombies called Dead Zone, and that is always a possibility, but Basically, what I wanted to talk about is the dead zone on a controller, and you can see here is my pink controller. Basically, what happens is these sticks, you have to imagine inside, in fact, this is translucent, you probably can't see it, but inside there's that stick basically connects to a circuit board, and it's got some electronics in it. I think they're usually potentiometers. I don't even know. I'm not a hardware guy, so to be honest with you, I have no idea what actually goes on in there, but what I can tell you is that the accuracy on these things is awful. So basically, even though this is back at 0, like we would all think of that as not, the stick is not doing anything right now. That is actually not what the electrical reading is on the stick. The stick right now actually thinks it's somewhere entirely else. And basically we can even demonstrate that by basically going like, okay, let's go in here and set a breakpoint, for example, somewhere, oops, that's not good. What's going on here? I didn't mean to actually modify my code. Yeah, so basically, I've got the stick. The stick is back at its neutral position. I'm going to go in here to our code, and I'll just take a look at what happens when we pull it, right? So I'm going to pull it. Here we go. Let's get down in here. So basically, we pull this thing, and what did we actually get back for our x and y? You can see that they are definitely not 0, right? There's noise in there, and so the location of the stick, when it is quote-unquote centered, is actually not 0. And that's not actually a bug. That's just that's the tolerances for which these controllers are designed to operate. Like, they aren't designed to give back an exact 0 when the thing is centered. They're designed to be somewhere around 0 when the thing is centered. So, in order to correct for the fact that the player thinks the stick is centered, but the stick is not centered, what we need to do is apply a dead zone, which is a region around 0 where we will effectively consider it 0. We are basically widening our opinion of 0. And you can see that X input basically defines these values that they want you to use in order to be compliant, and so we will use them. Basically what they are, if I can get the MSDN documentation with them here, let's see. Hello, come on. There we go, internet. Go, internet. Basically what happens, if I can scroll down to, there we go, the dead zone here. So basically what we want to do is we want to use that dead zone, this input dead zone thing, which they have actually defined it again. I don't know why. It was there defined to begin with. I don't know why they did that. Point being, here are the dead zone values, right? Basically what these dead zones are saying is that any value for the left thumbstick that's less than 7849 short, that's a 16-bit value, right? So you can kind of imagine what percentage that actually is if we wanted to do the calculation. So, oops, calc. So basically, if you imagine 32768 is the maximum signed short value negative that it would be. And so if we actually look at what percentage that is, 32768, if we say 7849 divided by 32768, like that, you can see that that's, well, if you look at that number, it's surprisingly large. It's somewhere between a fifth and a quarter of the stick is just flat out being said is not usable, right? It's like the Xbox standard, I guess, is basically saying we are going to manufacture stuff that is up to almost up to a quarter of the range is just gone, right? In any given direction. And it's even worse for the right thumbstick. That's even a little higher. That's closer to a quarter, right? So that's let's see here, divided by 32768. So that's actually over 25%. So that's just to give you an example of how large that dead zone is. It's big. So what we want to do here is we want to basically just pretend that if we get values that are in that range, that they are not really going to be considered valid values. We're just going to, if they're inside that range, we're just going to treat them as 0. So in order to do that, I'm not sure exactly how I want to do that. I did the range mapping here. I feel like they're basically saying that this needs to be applied in either direction. They're not really clear on the difference because if you'll notice, the negative range is different than the positive range. Like I talked before, it's 1 greater. So it's a little odd that they're the same. We don't really know very much about it. So we're going to have to take their word for it. But it might be nice if they had done a little more documentation here to talk about the difference between positive and negative in this case. Because like I said, negative 32768 is a negative value. 32767 is actually the positive value, right? So there's a difference in range there, and we're off by 1 a little bit, so it's odd that they didn't respect that. But those are the dead zone values. We're going to use them the way they suggest to use them. Basically what we're going to do here is we're going to change our processing to basically start out by saying that the x and the y are assumed to be 0. We will then go ahead and access excuse me. We'll go ahead and access these values. We'll say if if the pad, well, you know what? I can actually do it just like this here. So I can basically say this whole thing is predicated on this being lower than the dead zone in this direction, right? Like that. And this thing is predicated on it being higher than the dead zone. Now, I don't remember if they said higher than the dead zone or higher than or equal to. They did say higher. Yeah. Now, this is, well, that's an interesting thing. It's a magnitude check. Okay, that's fine. We'll talk about that in a second. All right, so anyway, this right here is basically, this right here is just saying, all right, we were already checking so that we did the divide by the right value depending whether we're positive or negative. And if we look at what's happening here, we can basically say, all right, now what we're doing is saying, don't even set the value of x unless the value on the gamepad is already less than the dead zone for negative or already greater than the value for positive. And so it'll just leave it set at 0 otherwise, right? So you can kind of see the way that that works, right? And then similarly, we can go down here and set this guy and do the exact same thing. This guy will just be doing the same thing. This is our left thumb dead zone as well, right like that. And pad s thumb ly greater than. And now the only thing that we have to do is we want like the negative, right? We want it to be less than the negative version of the dead zone. So we need to just stick a negative in there, right, if that makes sense, because otherwise we'd be checking if it was less than the positive value of the dead zone, which a negative value always is going to be. So we want to make sure we catch the range on either side, right? So that's really it. There wasn't a whole lot else that I wanted to do there, but I just wanted to make sure that we got that in there so we can get rid of our to-do. And then we can also say, well, these two things look very, very similar, right? They're almost the same. So what we could do is we could change this to a Win32 process x input stick position, right? Or stick value, I guess we could call it. And then we can go and say, all right, we know that we would pass it the LX, so basically we'd pass it whatever the value is. We'd pass it the thumb dead zone value that it should use, and then we pass it basically the place to write that into, which actually is going to be a little problematic for us because we need to sort of group the left and the right stuff, which is a little tricky based on how we've done it. I could pass values to each individual one. Maybe that's the easiest thing to do. Or I can sort of short circuit that process for now and not go the full route and just do this. So what I could do is say that, right? Hopefully that makes some sense. So we'll basically say we'll just use that same path, and then down here we would do, you know, this sort of thing, pad with the ly, doing the same thing there for the dead zone. And you'll notice we're using the same dead zone for x and y, which seems weird, but I guess that's how the controller is supposed to work. Have the same dead zone for both. I don't really know, but that appears to be what they are suggesting. So I'm going to go ahead and pull that out so that we basically have a function that does exactly what I just said. Here we go into our utility function here, just so I don't have multiple copies of this function, and that is this. So it's going to look like something which basically just takes in first the short, I believe, is what this is defined to be. It is a short, is it capital short, I think is what they are? Let's take a look. What is the name here? It is one of those state structures, X input state. Just want to verify that it is short capital. That's what they actually are using for their 16-bit. We could use int16 if we wanted to, but I want to use the actual thing that they have defined it to be. So it's a short. That's what I thought. So basically up here, we just want to take that short value, whichever one we're taking. So this is the value. And then we are going to take the dead zone value as well. We'll call that the dead zone threshold. And then inside the function, we just do exactly what we did before. We basically now just use whatever value was passed in as the, there we go, and we use the dead zone instead of that so that we can control if we want to use the other stick at some point, we can use it. And then we have the result equal to the value as well. So that is basically all there is to it, nothing more. And then we can return that. So there is our processing for the stick. Looks pretty good. I don't know why that happened. That was a cut and paste bug. And so there we go. Now we're compiling. And I don't know if we were actually working yet. We may not be. Oh, right. I can't test this yet, though, because that is on controller 1 now. So what we need to do is now actually in our code that someday will actually process real controller input. Hopefully that'll actually probably be pretty soon. But basically what we need to do is set that is analog, so that's set to true, and we need to actually check that controller. So basically what we're going to do here is maybe we will just flat out check all the controllers in a for loop right here. So basically we'll say controller index equals 0. We will go ahead and, oops, that's no good. Switch to overwrite mode accidentally. We'll basically just check all the controllers like this so that we'll pick up, because we were only picking up the keyboard now because it's controller 0. So I'd rather just do this. I'll change input 0 to be controller like that. And we will go ahead and grab every controller in a loop. And for each controller, we'll basically just do the operations directly for each one. Now that basically won't work for tone hertz. Tone hertz will get overwritten, so the last controller, whoever the last controller is to report is analog, will overwrite tone hertz. But that's okay for now. We don't really care about that. There we go. Looks pretty good. Nice and stable. And that dead zone processing seems to be working as well. There's no jitter there. We can see as well when we start up, we no longer have the occasional, joystick is moving problem. That looks pretty good. I should also check what happens if I unplug. There we go. It is unplugged now. And now I will plug it back in. There we go. And there we go. All right, so that looks pretty good. However, I don't understand. I'm not sure why. Let me see if that happens again. No, it didn't. I'm not sure why we were having that weird tonal thing happening. Yeah. Well, seems okay for now. That was a little suspicious. I want to check. When we actually go, I guess, and do sort of more thorough checks on some of this stuff, we'll see pretty quickly if that's right or wrong. But everything else seemed to work properly, so I think we're in good shape. Anyway. So that is all I really wanted to do for that. Now, I want to also make a couple changes to the way the stick stuff is handled. And I thought about this. I was lying in bed and I was thinking, and I'm like, oh, okay. I was falling asleep, and I'm like, oh, I should really have done the stick handling a little differently. I realized there was a smarter way to do it than what I did. At least I think there is. I don't know. It's always, every time I write code, I try writing it a little differently to see if I can get a little better, and sometimes I get worse, and sometimes I don't. It's hard to say. So I always try to come up with new ideas and be like, oh, maybe let's see what happens if I try code that looks like this, and then I go and say, ah, no, it didn't work, that was bad, or oh, there was a good thing there, I'm going to remember that and do that thing again. So what I was thinking is basically what I'd like to do is I'd like to treat for this game, I think I'd like to treat the stick as if it's always essentially a D-pad and the things are buttons, but then just have an extra piece of data that says what the average motion of the stick was, so that if you are doing sort of motion, it can be smooth on the analog side. But you can still use it, you can still look at it as if it was buttons for the purposes of like double tap, like that dash thing I was talking about. Because what I realized is the min-max thing, this thing that I was proposing, is actually kind of dumb. It's way harder for the game to use that as a thing, and it's way harder for that to capture the thing that we want, as opposed to just doing something like this, average x, right, average y, for that stick position, and basically that's just only if analog is on will it get those, and I could say that this is something like that, right? Basically, what I should do is have these be defined as buttons as well. Like basically the up, down, left, right should actually be now defined to be buttons. Should be D-pad and buttons should all essentially be treated the same. And that way when you look for things like dash in a direction, you just look at the half transition count for the direction. And if the half transition count is 4 or whatever, or 3 I should say, you know that that's a dash. That's it. And you can sum those over time. You look at the half transition count. If you get one half transition, you look at like how many half transitions you got in say a quarter of a second, and that just right there, that tells you what your, whether the dude dashed or not. So I think it's just smarter to do it that way. And so maybe what I'll do is I'll break these up into stick and button or something like that, right? I don't really know if it should be button. It's like I kind of want basically like I guess action, like that kind of thing. There's the action and direct and move. I guess so. It's move and action. That's good. I like that. Move up, move down, move left, move right, and action up, action down, action left, action right. That seems a little bit more interesting to me. And because then that way, we basically have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. We basically just have 10 buttons now and the stick average. So hopefully that makes a little bit of sense why I wanted to do that. I know if it's a little confusing, I apologize, but it's just something I was thinking about, and I was like, that's kind of cool. I'm going to try that. And then we'll see when we go to actually make the movement of our character, which will be pretty soon. It'll probably be a couple of weeks when we're actually doing movement tuning. You'll see how I use it, and hopefully that'll make a little more sense then too, as to why I wanted to do that. I'll be able to show like, okay, here's the code of why I think that was good. So I think that's a more interesting way to do it, and it means that basically these become no-brainers. The keyboard now gets passed through totally directly and correctly, since those were they are essentially buttons now, right? And so there's basically like W is move up, right? A is move left. S is move down, and D is move right, right? And then these are now the action buttons: action up, action left, action down, action right, right? And that is like that's it. Like that just works pretty much. I don't think that we even really need to do anything else for the keyboard. The keyboard is pretty much done. And so then all we have to do is down here say, oh, okay, that changes a little bit the way that this thing is handled. Basically what we have to decide is what that threshold is for whether it's moving left, right, or up or down. I guess at first we might say that that should be just the dead zone. If you're outside the dead zone, that's a left. If you're outside, it's a right. So I think that's probably what we want to do. So basically what I would say is now we're just going to we're going to get rid of all this min-max stuff entirely. It doesn't need to be there at all anymore. We can directly set these values. So basically we can do this sort of thing. Let's see here. There we go. We can basically directly pull those sticks and stuff them into stick average X and stick average Y, and that's fine. But the other thing what we can do then is now say that we are going to use these stick average things to determine whether there was a trigger on one of these buttons. So basically what we will do there is say, I guess we would do this. We could even make a synthetic version of, we could even just call this function, really, if we wanted to. We could say process digital buttons with fake move buttons, essentially, and then actually just full on pass. Yeah, that's not a bad idea. Let's try that. I'll say what I'm going to do in a second here. Let me just finish making this code change, because we need to actually change. These are now action buttons, like that. There we go. And basically, I think that's basically it. That looks about right. Everything's good there. Okay. And we should probably, I feel like these guys should come in here too, while we're cleaning things up. I wonder if we should go ahead and say start and back are in here as well. Back and start. So let's do that as well, since we're, it's free. This is one of the nice things about pulling out code properly, is basically you can just kind of you don't really have to do much work to start processing other stuff. So there's the start button. Oops, it's getting behind my head. Don't want to let that get too far behind my head, or you can't see what I'm doing. So there we go. All right. So let's go ahead and just throw those in there while we're at it. Seems like a good enough reason to do that. So this is stick average x and stick average y, just to get those ported. We've got action down, and now we got to clean this up. So that's fine. We will clean that up in a second. Is there anything else? The start button, oh, that's not good. Gamepad should probably just be start and back, I would assume. Is that right? Yeah. So there we are all ported, and now I can just go ahead and do the thing that I was going to say. Basically, I've already got this function written that does the processing for the button exactly the way I want to. So what I'm going to do, I think, is just go ahead and use a fake value as if we had buttons for these guys, and I'll just set that. Value to basically be whatever, to be set properly in the case where the sticks are in the position I think they should be, and not if they're not. So basically all I'll do is say, I've got this stick average x, and maybe we'll basically say, I don't know, I mean, for the purposes of doing dashes and treating it as a button, if it's more than halfway, I don't know. It's basically like we're going to have a threshold value, basically, right? And we've remapped things between 0 and 1 now. So we need a value between 0 and 1, so halfway would be 0.5, right? And what I could do is say, well, if the stick average x, right, is less than the negative threshold, so if it's negative 0.5, right, then fake move buttons is 1, otherwise it's 0, right? So it's basically, in fact, all I'm really doing is this. I'm just doing that right there. That's it. That's all I'm doing. And so I basically made a fake button bit array that's set, it's got the bottom bit set in the case where it's exceeded the threshold and otherwise it doesn't. And then I'm just going to say basically that move left, which would be stick average x, if you're moving left, and if your stick average x is negative, then you're moving to the left because negative is mapped this way and positive is mapped to the right. Basically, I think that's mostly all I wanted to do. That's it. So yeah, and then I just check for the threshold in the opposite direction, do it for y as well. And so now I can just call that same function, which does the counting properly, and that's it. Oops, I deleted my threshold. That was a mistake. Threshold equals 0.5. And that, Reek32, that's an interesting typo. That is really all I wanted to do for the stick handling there. And it still works fine on the average. Now, of course, we still can't use the keyboard to control anything other than just the action buttons because we're only checking for analog controllers in here. And so we need to also make sure that we handle keyboard controllers. So if the controller is not analog, which is the case of the keyboard, what we probably want to do is say, all right, let's process the blue offset at least. So we'll say something like, if that controller that we're looking at here, which we know isn't analog anymore, if it's, let's say, so it's stick average. So if it's move left, then we will go ahead and subtract, something here. We'll subtract 1, let's say, and if it's move right ended down, we'll basically do that. So basically, if you're holding any of those down, we will go ahead and update it that way. All right, there we go. So there you can see now we've got our keyboard input working. Awesome. All right. So I think that's basically it for what I wanted to do input cleanup. Let's check the to-dos a little bit here just to make sure that everything is happy about that. Let's see, to do D-pad. Oh, we can knock out this to do as well. With the D-pad, we can just treat the D-pad as another one, as basically as forcing our stick average if we wanted to, right? What we could do right here is just overwrite the stick average with the D-pad in the case where someone pushed the D-pad, right? So what we can do is say right before we do this with our stick average, right? What we can do is say, let's say if the D-pad up was down, right? So they're pushing up. Then we just flat out set the stick average y to be -1, right? So it's the full on. It's as if you're just cranking all the way. Although now that I think about it, I don't know which way. I don't know which way the stick goes. Does the stick go? Is it negative for up or positive for up? I have no idea. It should probably be positive for up, shouldn't it? I don't know. Let's find out. Let's see. Of course, the documentation doesn't bother to tell you, because why would you do that, right? Let's see here. Left. Each side of it. Let's see. Okay, so they just put it in the wrong place. So it does tell us. Negative values signify down or to the left. So negative is down. So stick average Y should be positive if the up button is pressed, right? Makes some sense. We'll go ahead and flat out overwrite with down as well, right? Makes sense. Hopefully this is self-explanatory. All I'm doing is basically overwriting the stick value with the D-pad in the case that the user used the D-pad, because of course if you moved your hand off and started using the D-pad, we'd want to use that, because if you were trying to use the stick, presumably you wouldn't be fussing with the D-pad. So it seems like a pretty low-risk way to allow you to use the D-pad and not have you have to pick. You can just use whichever one you want at any time and switch between them, which seems preferable. So I should be able to do that, and now I should actually be able to use the D-pad for stuff as well, which I can. There we go. All right. All right. That's good. So let's take a look at this here. What else do we have? Oops. That's not good. All right, so here, stick average Y, I did the negative, I forgot to take the negative out on the positive case. So that's not fun at all. All right, so there's our move left. Okay. So basically, I think, I don't know, I might have some more bugs in here. I did that pretty quickly. Obviously, we're going to have to test this, and we will be able to test it very easily once we actually have the game up and running. We'll draw out the stick positions and kind of go through, run through a little test to make sure that it all moves the way that it should move. And basically, yeah, I think that's about it. That to do is about polling, which we will do a little later. Let's see here. And I think we don't have a to-do. We should have another to-do in here. To-do, Casey, need to not poll disconnected controllers to avoid X input frame rate hit on older libraries, just so we know that needs to happen as well. I will be showing how to do that much later in the stream, but yeah. So anyway, I think that is mostly all we needed to do. We have our keyboard input going. We have our to-dos out of there for things. These are all to-dos that we're going to be doing for other stuff. We could make that zero memory thing. Let's see, need to not pull disconnected controllers to avoid X input frame rate hit on older libraries. That's in there, yes, and we'll do that. We'll check the packet number when we do that, and that looks pretty good. That looks pretty good. I suppose there's one thing we could do more while we're just in here, just in case it makes our life a little bit easier later, which is we could also have is connected, basically, so that we can set whether or not there actually is something on there. We might as well throw that in now, and that way when we're testing things, we can actually test that as well, just as a little, like, you know, get things working in the game and so that it actually does the right thing there. So basically what we can do is say, all right, the new keyboard controller is always connected because we're just assuming that there's a keyboard. Later on, we'll do stuff with that where we actually pull from multiple keyboards and all kinds of fun stuff like this. But for now, we know we just always have one keyboard, and that's fine. And in here, we basically know that this is connected if we get it. So new controller is connected. Let's see, new controller is connected is true in here, whereas it is not true in here, right? So there we go. So I think that's it. I think that's it. That is looking good, my friends. That is looking good. Uh-oh. That's no good. That is not looking good. That's not good at all. What did we do? We made a grievous error, people. And that is not what we should be doing. That is unfortunate. All right, so basically we have, let me just, before we go look at that, I wanted to verify what we're doing here, make sure everything's kosher. So we did everything that we need to do for our keyboard controllers. That's all fine. We got the input, and that's nice. We should, in theory, always have the right number of controllers. Do we have that? I should also put in some assertions here. One thing that I would like to do as well is for getting the controllers out. I'd like to go ahead and make a thing for that. I'll show you what I mean by that. I want to basically make a thing. In fact, I can just write it right here. Something like this. Get controller, and you pass it the game input, and then I just say controller index out of that. And basically, the only reason I wanted to do that was basically to make a bounds check. To basically just make sure that people aren't asking for stuff that's out of bounds. So basically what I'm going to do is just assert when we call that, that the array count of the input controllers is correct, because we're starting to be a little fiddly there, and I want to sort of make sure that that's not going to cause a problem. Basically, we'll do that, and then assuming that it is, then we will basically just access the array. So this is literally just putting in the kind of thing that this is basically like higher level languages often do this for you automatically, like bounds checking, and just give you an error. We can do this pretty trivially for our own arrays. People who write in C++ might make a templated class for these sorts of things that do bounds checking, and we'll be doing some stuff for that later as we kind of get further on into making our own sorts of library stuff. But for now, we kind of have to do it the old-fashioned way, which is basically just to do the check ourselves. So here we go ahead and say we got the controller index, and that is there. We pass the result back, and that should be good, like that. And basically all I want to do is just now make it so that everyone has to go through that. So what I'm going to do here is a little trick that I like to use, which is basically like insert a bogus character into the definition of something to see where it is used. So that basically I can just go through all my code that was accessing that directly before, and basically not access it directly if I don't think it should be accessed directly. So I look at each individual one, and this, for example, is getting it, so I'd rather do get controller here, pass it the input and the controller index, and have that return the value, right? Same thing with these guys. Those should be get controller, pass it the thing, and the index, like so. Same thing here, get controller, new input, pass the value back, right? And so that's just, you know, again, this is just basically checking for bugs in making it easier for us to find them, especially because we have a bounds overwrite we got to go find in a second here. This is the sort of code we need to start putting in to make sure that we don't make stupid mistakes when we're doing stuff. So there we go. And we'll get controller here, new input, our controller index, there we are. And let's take a look. Oh, yeah, well, I already spotted the bounds overwrite. That's kind of obvious. You can see what's going on here. That was just wrong, actually. What we needed, this computation was wrong. You know what? I will explain it fully. I shouldn't go fixing things before I actually say what I'm fixing. I saw what the error was because I kind of knew where the error was going to be, and it was there. So we'll push that for a second. And this is actually, I'd rather have the nice demo of showing you that this bounds checking was valuable. So I shouldn't. I'm spoiling my own punchline. Who wants to spoil their own punchline? That's just silly, right? We don't wish to spoil our own punchlines. We wish to have our punchlines land at exactly the right time. All right. So I think that was everybody. What's going on here? Hello, Emacs. Come back. There we go. All right, so we'll go ahead and build that. There we go. And we should, bam, right there. That is exactly what we wanted. You can see that our assertion has caught the error. And the error is that this controller access is out of bounds. It is passing a controller index that's too high. So why is it doing that? It's because when I was fussing with that routine, I sort of slapped in something that's just totally erroneous. Basically what we want to do here is we want to make sure that we don't go above the controller value. That is, we don't want to sample controllers that would be outside our range. So we are saying that we'll support 1 keyboard and 4 gamepads. That was sort of what we were saying the game might allow for input. So we have 5 input slots. So what we want to do is make sure that xuser max count never actually goes above that. And so what I wanted to do was clip that here. So what we could say is, the way I was saying is 1 plus max user count. That will end up making it equal 5. So this will actually be a loop of 5, which then adds 1 to the controller index, which allows it to write to actually the 6th entry. That's no good. That's just a bug. What we actually wanted to do here is still only count up to 4 because we're already doing the increment by 1. So this needs to clip. This needs to be user max count. And we basically need to make sure that the max controller count is actually equal to this value minus 1. We need to be like less than the array bounds minus the keyboard size, right? That's what we were actually trying to do. So that was kind of just a silly, that was just a mistake. And so now we should be back to goodness, and you'll notice we don't get the assertion anymore. So that was good, and I think that basically finishes up. I don't think we've got anything left to do really there. That's seems like we've got everything. We have all of our inputs. Oh, you know what? One thing we could do in the last seconds here before the stream is about over is we could go ahead and map escape to be back, that back button, or the start button, let's say, and back could be a space. I don't know what we want. We've got the shoulder buttons for Q and E, and then I don't know. I guess back and start. Back could be backspace. I don't know what on the keyboard should be mapped to the back button. Maybe the space bar. I don't know. I don't know. We're just gonna map these and we'll change them if we need to. So there we go. Just so we have those in there. All right, everyone. We ended right on time, and we did exactly what we wanted to do today, which is clean up our input. So now we have keyboard input and stick input going through properly, handling the dead zone. You can use the D-pad. You can use the analog stick. We even are tracking transitions for using things like double dash. So I think I am pretty happy with that. Now, we may have some bugs in there because we haven't tested it very thoroughly yet, and we will be doing that kind of in the game code. We'll actually put the test stuff in there because we're going to want our test stuff to be shared across the different platforms, right? So you can fire up your Mac port or whatever and take a look and make sure the stick's working there as well. So we'll take care of that in the platform code next week. But for right now, I'm feeling pretty good about that. That looks pretty good. I don't have any reservations about what we've done there. We eliminated a bunch of to-dos. We still got some in here that we should probably take a look at. But basically, we're down to just a couple things. Tomorrow, we'll focus on the frame timing. And then we'll kind of go through here and clean up some of these other ones. We'll focus on see if we can get frame timing done tomorrow. It might spill into Thursday. And then Friday will kind of be a general cleanup day. And I think we might make it. We might finish up all of our Win32 stuff and be in real good shape by the end of the week, which would be pretty awesome. Basically, the 20-hour completely explained Win32 game prototyping layer is a pretty darn good thing. I think we should all be pretty proud of ourselves. If you're not proud of yourselves out there, well, you should be, because I think we did a lot of stuff in a short amount of time, and we kept it very concise, and the code is looking pretty clean. Again, the important part, like I said, is it doesn't matter how gross this Win32 layer is either. We don't have to care about that because interfacing with Windows is going to be a little gross. All we want to make sure is that this is clean, this is nice and clean, so that our game can be nice and clean, and it is, I think, looking pretty nice so far. It's such a clean boundary, so I'm pretty excited about that going forward. I think it's going to be pretty cool. So, with that said, we will now go to the questions. Please make sure you put C. Muratori in the question when you ask it, so I will see it on the little filter. And also, if you could, keep the questions to code we did today or in some previous day, not about code we're going to do in the future, because we will be doing the code in the future, and I will probably answer the questions in the course of actually showing you how to do that code. So with that, let's go to the questions. Let's take a look at what's going on. Let's see. So it looks like maybe some people caught a bug or typo. They were saying maybe there was all move lefts. What's going on here? Trying to read back through the stream. Check the array in the buttons union. Might want 12 now that you've added start and back. Oh, right. Yes, thank you. That is a good point because we want to be able to handle all these. I wish there was a way. So, okay, let's think about this for a second. It'd be interesting to know, is there a good way we could make sure that we could catch this bug? Like when we add stuff in here and we want this array to have all the things, right? And so what we want to do there is basically we'd want to do something like when we come in at well, this actually should be cross-platform. So when in here, we want to do something where we can sort of assert that, for example, I guess the address of the last button we know about, right? So button start equals the length of this kind of thing. I don't know if that makes sense. But basically, like, we might want to say, let's assert that, say, input, let's see, input controllers 0 start, that is equal to, well, I guess how can I do that? I could subtract, yeah, so I guess what I would say is, let's say that start, the address of start, this is going to be pretty janky. The address of start plus 1. So I'm going forwards a little bit there. The address of start plus 1 well, okay, guys, the address of start. Let's do it this way. Take the address of the start button, subtract it from the address of the move button, like this. Well, I could even just do button 0, right? Like that. The address of button 0. That should equal the array count of the buttons, like that. So, right? Now it's going to be off by 1 because it's actually should be 1 past that. So it should be the array count of the buttons, I believe, minus 1. That's the actual check. I think. Game controller input does not have, oh, right, sorry, don't need it. That is actual structure. So basically what I'm trying to do is do some pointer arithmetic here. Now let's see if that works. Yes, good. That caught it. Of course, I'm not sure if it's actually still correct, but that caught it. And then it should be 12 now. Let's see if that works properly. Off we go. Yeah. So basically what I did here was I just wrote something where I said, all right, let's take where the start button is in the layout of the structure. Let's subtract the base of the button array from it, which is the start of this whole thing, right? And I want to make sure that the number that I get back is equal to 11, right? The number, I want it to equal the array count of these minus 1, because again, we're using the pointer to start is going to point to just before the start button structure, right? It's pointing to the start of it. So if I subtract it from the base, I'm going to get 1 less than the total count that there are. And so I'm just checking to make sure that matches. Now this isn't perfect because we can still do this, and this won't catch it, right? That makes sense. But it at least checks that the last button that we know about in here is correct. Now, we could do something else. We could use a get button function that checked. I don't know if I want to go that route. I'm also not sure if there's any way... Oh, you know, duh. I've got one way we could do it. There's a pretty easy way we can do it, in fact. We could just do this, I suspect. Game controller input buttons. Duh. Why not do it this way? Can I do that? I don't know if I can do that. Yeah. Oh, no. I guess it has to be anonymous. It's not going to let me name it, is it? That's too bad. I was hoping it would let me name it. Because if it let me name it, then we could just say the size of this thing. But I can't do that at the moment, unfortunately. And still keep it anonymous, which is what we kind of wanted to do. Now we could go and make it non-anonymous. We could make it be a thing that actually has a name, right? And we access off the name. I don't know if we really want to do that. Seems like a little inconvenient, but maybe it's better to keep the bugs. You know, if I basically said this, then we could just do the assertion that this structure was the same size as this array, which is kind of what we would like to do. Well, one other thing we could do is we could do something like this. I'm not happy with any of these, really. We could insert a fake button that doesn't mean anything at all. And then we could just say, well, it's that button it's got to be equal to the array size, right? So it's like a Terminator button. And now, if we go in and add a button, as long as we don't add it below the Terminator, right? If we always add our buttons up here, then that assert will fire properly for us, right? Bam, and it caught the error. So maybe that's good for now. I don't have to think about that. Maybe we do want to just name it and deal with the name so we can do it more cleanly. So I'll do note Casey, all buttons must be added above this line for now, and that's something. So we'll leave it like that for now, but thank you for catching that error, because that was a good one. That would have been annoying. Let's see. There's a lot of questions. We're not going to get to all these. There's too many questions. Is that some copy pasta, or is it really supposed to be all move lefts? I don't know. So is there somewhere that it's actually wrong, where we're doing move left multiple times and shouldn't be? Yes, that is copy pasta. That is totally copy pasta. Thank you for that. So basically, I just missed these here. D-pad. Oh, we didn't test the D-pad yet, right? Because we ran out of time. So we would have found this as soon as we tested the D-pad. I was like, how come we didn't see that? But that's why we haven't done that yet. So basically, I just need to go ahead and make these be the actual values that they should be. Let's see here. Oh, we said down was negative. That's what the documentation said. So down is negative. Get out of my way so I don't hit my head, pun intended. So yeah, that was just copy pasta. That was supposed to be that. And I can test that now too, can't I? I can test the D-pad. There we go. Yeah. Yeah. Should be right. Yeah. Okay. Well, oh, you know what? No. I take it back. So the reason we didn't catch that is we did test the D-pad. The reason we didn't catch that is that's just for the button. We don't have anything that tests those values. That's just for the thing for checking like dash and that sort of stuff. So yeah, unfortunately that unfortunately is not actually going to, that's not going to help us. So we're going to actually have to test that later. We still don't know if that's working properly. We'll have to test that later. You know what else we should do while we're on the subject of things that could happen? Another thing we should do is maybe fake the stick average. I don't know. We could, nah, let's not do that. That's dumb. Well, okay. So let me just tell you what I'm thinking here. So when we use the D-pad, we should probably change to say that the thing is not analog anymore, right? I don't know. Don't you think? Like that way it knows, like if we see input from the D-pad, the game should probably switch to using the same kind of control scheme as it's using on the keyboard, where it would do like smoothing and stuff for you. So I feel like maybe we want to set this to false if we do any of this nonsense. I think I'm going to leave that in. Yeah. All right. Let's see. Could it be good to apply some integration on the digital keys so we don't just set the value to binary -1, 1? That's a good question. I don't think so, because the way I want this to work is I basically want the... I'm only setting the stick average so that it sets the move left, move right, move down, move up buttons. And then I'm setting the is analog, and I'm going to let the game use the is analog flag to say, oh, I'm going to start using buttons now instead of the analog stick for this controller until it goes back to using the analog stick. And I'm hoping that that will kind of be the thing that works best there. Now, it's a little bit tricky because it's like, well, you know, we probably also don't want to set is analog to true unless the stick is actually being used. Something like this. So if the stick average is not equal to 0, or if the stick average in either direction, right, excuse me, is not equal to 0, something like that, that is more like, okay, now we've got, now we've got something where the game really does know whether using the analog stick or the D-pad at any given time, and it should do, so that integration that you're talking about to smooth out using the digital, that's will be done by the game. Because it's going to have to do that for the keyboard as well. And so we want to make that unified. Can you talk about the dead zone being round versus rectangular? And at hardware, USB, HID, and X input... oh, you're saying who... I'm not sure what you mean by at hardware, USB, HID, and X input API layers. So, as far as I know, the dead zone is literally something that's only software side. Like the hardware is reporting just like its potentiometer values or whatever it's what I don't know what they use nowadays, but whatever they're reading, they're just reporting that electrical level like turned into something. And so when you get back the short, it's just some kind of quantization of the electrical level. And so as far as I know, on USB, that's just on the bus, it's just getting passed as part of the HID page. Like here's an X, here's a linear mapped value, and here it is. As far as I know, I've never actually gone and looked at what the HID code pages look like for these, but I think it's basically just passes that value through, X input hands it to us, and then it's up to us to basically do that dead zone processing. And X input has pound defined what it says the spec is for the dead zone on the controller, but I think that's it. I don't think there's anything else to it. As for round versus rectangular, I know nothing about that. I know that they have defined it to be rectangular, and I guess that pretty much makes sense if you think about it. I don't know the inner construction of this thing, but if you imagine that there's essentially two potentiometers, or two whatever they use, like I said, to read it, one for the horizontal and one for the vertical, then they're both going to have their own error. And that error is not going to be circular, right? It's not going to be based on how far you've gone to the left necessarily, whether the y is going to be more or less error. If they're read independently, the error could very well be rectangular. And so if the error is rectangular, then you don't have much of a choice but to clip the error rectangularly. Now, what we can do in our own code is we can go and try to do some better dead zone processing if we find it to be a problem. This again is the first pass on the input stuff, and so we'll have to go look and see basically what we think once we're playing it, whether we think it's working well enough for our game or not. And if it's not, we may have to do more fancier stuff. Like changing how this works in a sort of gradual sense. So that basically when you come out of the dead zone, that's at 0 and it eases in, instead of right now when you come out of the dead zone, you're going to be at 0.2, right? Because we know that's where the dead zone is. So you're going to be, the lowest value you can report for movement is 0.2. So maybe we don't want that. Maybe we want it to be clipped down and to do the dead zone processing in a different way, right? Like you could imagine, I don't know if we want to do this, but you could imagine, maybe we should do this. I don't know. I mean, I don't know. What do you guys think? What I'm trying to say here is what we could do is it might be better to have that value go smoothly from 0 to 1 instead of jumping up to 0.2, right? So I guess what I'm proposing is, one thing we could do to make the dead zone processing work a little better is we could basically say, well, all right, we essentially know that negative dead zone threshold is not counted. So we need to recenter our value so that basically the dead zone threshold is subtracted away from the divisor, right? And the value itself, which is of course negative, has dead zone added to it to bring it up to 0 in the appropriate scenario, right? This is what I'm talking about. Does this make sense? I don't know if this makes any sense to anyone. I'm just sort of proposing this as a thing that we could do, right? Does this make sense? So basically what I'm saying here is normally what would happen, and I can go to the diagram for this just to make it a little clearer. Go to the diagram, because there is actually only one. We've actually just always had the same version of paint up, and I just clear it every time. So literally there is the diagram. Basically what I was saying is, we've got this scenario where basically there's a dead zone here, and we've got stick values, and those stick values start being, whatever they are, right? This sort of thing. And we're basically saying that anything in here, X input has told us is noisy, right? We can't count stick values in here as actually being valid movement that the player was trying to do, because it's just random noise on the line. So what happens is, if we look at the stick position, right, inside the dead zone, as it moves outside, let's say he's moving the stick to the right, so he moves it in this direction, right? What are each of these values, right? Here's the dead zone value, and I guess we said that was 25%, so here's maximum, right? What we might want to do, if we map it just directly so that this right here is 0 and this right here is 1.0. I got my head in the way there a little bit, don't I? Let's try this again. Let's try this again without the Casey head. Right? So if I'm looking at the x-axis, right, if I'm looking at this span here, I could map this end to 0 and this end to 1, right? But what would happen there is as the user moves the stick, like this, when he crosses the boundary, when the player crosses the boundary, it's going to jump right from being 0, which is what we were reporting for the whole time it was in the dead zone, to being essentially 0.2 or somewhere around there, right? 0.25, something like that, right? It's going to jump right to 0.25. So the only values that the game will ever see are between 0.25 and 1. Which is kind of confusing to the game if you think about it, and basically then the whole game would have to be tuned, assuming that the lowest value is 0.25 on the stick, which doesn't make a whole lot of sense. So what I was saying is, well, let's subtract the dead zone variable, the dead zone area away, and just treat just this range here as 0 to 1, right? That's what I was trying to do. I don't know if that makes sense. Let's see here. Let's see. Hopefully that makes some sense. All right. So yeah, I don't know if that makes sense or not, or if it's not an appropriate way to do it. Someone was saying they actually do have a round dead zone defined. Let's see if that's actually true. Let's see here. If it's actually a round dead zone, we can do this even better. Let's see. Round dead zone. Dead zone. Can be used as positive edge to filter something. And because they don't actually say here. They don't actually say. Well, okay. We can do some extra reading. We don't have a whole lot of time left in the stream. We can do some extra reading to see whether it's a round dead zone or a non-round dead zone. It's been a long time since I've read any X input documentation. So let's just do both, and then we'll just use whichever one we find to be correct. So let's say this is a round dead zone value. If it's a round dead zone value, then that basically means the total length of the motion on the stick is subject to that dead zone, right? I don't know if that makes sense. So basically what we would have to do is we'd have to do the dead zone processing as a pair, right? We basically have to say we're going to do dead zone processing on the actual vector value. So that would be something here. That would have to look like, well, yeah, that's going to have to be vector. You know what? That's going to, if that's true, and maybe that is true, we could go look and see. So this is something that I'm not going to be able to explain that in 10 minutes because I have to introduce the concept of Euclidean length, and there's no way that's happening in 10 minutes. That's just unrealistic. So basically what I'll say is to do this is a square dead zone. Check X input to verify that the dead zone is circular. Someone was posting a link, so I'm assuming that they checked it on the stream and that it is circular, or I guess we could say round. The dead zone is round, and show how to do round dead zone processing. But yeah, it's too bad it's round. It's actually better for gameplay if it's round, so I hope you're right about that, because that would be nice. And the only thing that's the downside there, it's going to take me longer to explain how to do round dead zone processing. So yeah. But thank you for writing into that, because I was not sure about that. Since the documentation here didn't say, as we were reading it, and that's really all I had to go on. We'll have to find some documentation on the dead zone. Let me check that page I was at. Maybe that page before had it, and we'll see if they say that it's round dead zone. And then we could know, assuming that this documentation is correct, which of course we also don't know. Just because it says one way or the other doesn't actually mean anything if we don't check it. We should probably check it as well. So let's take a look here. The dead zone. Okay, yeah, blah, blah, blah. Let's see. Not really saying yet. We can look at the example and assume that that's correct. But circular dead zone. Well, it says it allows the enforcement of a circular dead zone, but does it actually say that it is a circular dead zone? Yeah, so unfortunately, I guess you know what, we'll just table this for now, and we'll get someone who actually knows for sure. I will try to contact someone who would know for sure, because this just says their processing is a circular dead zone. But that doesn't mean that the hardware has a circular dead zone. The dead zone might still be rectangular, in which case us processing as it circular is only making it worse. So we kind of need to actually know whether the input dead zone is literally circular on the controller, and if that makes sense. So I don't know. I don't know. Yeah, because they're processing it circular, but that doesn't mean anything. That just means that they're processing it circular. But they don't say that the hardware was made with a circular dead zone, because if the hardware still has a rectangular dead zone, it doesn't help us. Does that make sense? I don't know if that makes sense. I don't know if that makes sense. But there's some links in here, so we'll check them out. Let's see. I'm 16 days behind. Is there a better way to catch up than watching all the days on YouTube? Yes, there is, but only slightly. Obviously, everything is important, so you got to watch it all. But if you go to the news and forum, if you go to handmadehero.org and go to the news and forums link, there's a thing called episode guide that has better annotation on it. So you can go to something like this, and it allows you to jump around the stream. So that is better than the YouTube system, but it's still all just watching the YouTube. but it does allow you to skip things you already know and that sort of stuff. All right. Oh boy, there's a lot of questions on here. I'm going to miss some. For the build.bat, you can build for Windows XP 64-bit using 5.2 instead of 5.1, but we don't actually need to do that because it's already building for 5.2. Also, the inline method for get controller. What happens if you pass in -1 for index? So you can, if you want to, for this, they were basically saying, should we check against those? You almost never have that bug. You can, if you want to, you can do one of two things. You can either do this, right? Which now makes it so that you know that the value is always unsigned. So if they did pass a -1, it would fail this array count by being way high. It would be FFFFFFFF. It'd be like, 4 billion or whatever. So you can do that, or you can assert that controller index is greater than or equal to 0, whichever one floats your boat. But that's basically, I mean, that's that's the long and short of it. You almost never have buffer underruns, though. At least I don't. I very, very rarely have buffer underruns, so checking against them is not so important. Buffer overruns, you often... I find that just the nature of the way that C code tends to work, you are very likely to write a buffer overrun. You are just not that likely to write a buffer underrun because you rarely go backwards with pointers. I don't know, that's just... It's weird. It's a bias. It doesn't really have to be that way, but that is just the way that code typically gets written. Let's see... Can you do struct inner buttons type and still get the benefit? Yeah, so that was what I was trying to do before. So for some reason, buttons type, like this sort of thing, it did not work. At least it didn't seem to. Yeah, basically like giving it a name ruins the anonymousness of it and makes it so that you can't access the interior without going through it first. So basically you have to do it that way as far as I can tell. Yeah, I just don't know. I don't know any other way to do it, unfortunately. There probably is a C++ 11y way, I would think, but I'm not sure. I don't get using Win32 prefix for function names but compiling to 64-bit. Okay, so basically that's just to tell us that this... So this code isn't actually Windows 64-bit. It's Windows 32-bit that you can compile as 64-bit. So actually all of this stuff, and we showed this on the last stream, all of this stuff can be compiled for Win32 as well as Win64. So it is not Win64 code. It is Win32 code. But we can compile in 64-bit when we want to, which we do want to because that's going to be faster. So basically, it's called Win32 because it actually is all Win32 clean code. There's nothing in here that requires Win64. So we are compiling for both, and that's why the Win32. If we had a function that only worked on Win64, then we'd call it Win64. Let's see. Let's see. I was thinking about for game processing input in a separate thread so it is frame rate independent, but I heard you could introduce input lag. Is that true? We are probably going to do some polling potentially in a separate thread as well. It does not introduce input lag. It would if you did it poorly, I guess. But as long there really isn't any reason. I strongly suspect that we will want to at least for educational purposes, if not for any real reason, do a separate thread for input polling, say polling the X input sticks. And as far as I know, there is no reason why we can't implement that with no lag. I cannot think of any reason in my head why that would have to be laggy. I may be forgetting something, but basically it would just stuff it in a queue and the main thread would pull it out of the queue, and you could do a lock-free queue even for something as simple as that. So there would literally not even be a mutex around it. So I don't feel like there should be any lag. If you did it poorly, there'd be a bunch of lag. But if you did it properly, I don't think there should be. You said a circular dead zone would be good for gameplay. Why don't you just make it circular? The dead zone would just be a little bit bigger. Well, the reason is because then you're just losing information, right? Basically, like, this is why I say I actually want to know what the hardware does, because I want to actually provide as much data as the hardware gives me. So if the hardware was specified this way, then I want to pass that to the game. I don't want to circumscribe a circle like this and take a bunch of valid data that the game could have been getting and throw it out. I'm saying it's better for gameplay because a circle means that you have the same resolution no matter what direction you're going in, so you don't lose resolution on the stick as you go out here. So I'm just saying the joystick is better if it's circular, assuming that it's still so an inscribed circle is better than this, which is why I want to know. So if basically you're saying if to be 100% explicit, basically we've got some measurement of the stick. We're saying that measurement is noisy. It's not accurate. So what I want to know is the noise on both axes, so we have a certain bit of noise on this axis and a certain bit of noise on this axis, which leads to this dead zone literally on the hardware, in which case that is how we should process it. Or are we saying that it's just the total distance that is noisy? It's just however far you moved it, so no matter what direction you move it in, it's still the same amount of noise. I find that hard to believe. It doesn't sound like how hardware normally works, but my knowledge of joysticks is from like 1990. So that could very well be possible nowadays. Maybe they've got better techniques for building joysticks. So what I would like to do, I'm not going to go by the MSDN code because all that said was we're going to process it as a circular dead zone. But who cares? That's not relevant, right? We don't care how they process it. We care what the hardware does. So what I'd like to do is actually go talk to somebody who knows the hardware intimately and say, what is the actual noise profile of this hardware? And I'd like to process it that way, if that makes sense. So we're basically out of time here, just trying to quickly see. Let's see here. I don't think there's any more questions that I can get to. Looks like mostly everything straightforward we could cover. It looks like mostly just discussion of circular versus rectangular dead zone. And I want to go actually get some verification of how the hardware works before I do that. But if it does, then we'll just do circular dead zone. We might postpone that till I talk about vectors. So we may have to postpone circular dead zone processing if it does turn out to be circular until I talk about vectors, but that's about it. Let's see. Yeah. Yeah. Some of these questions are good. Maybe I'll just let me do an extra 5 or 10 minutes here because some of these questions are good. There's a question about direct input versus X input. X input is easier. Direct input supports more devices. So if you want to support older hardware, you need to use either direct input or you need to go off the raw input or the HID system. Which one we do, I don't know, but we probably should support direct input as well as X input in the end, just so we can support older devices. Or we can just say, it doesn't really matter, it's just an exercise in Win32 programming, and maybe that's not a useful thing to teach on the stream. I don't know. Yes, direct input is much messier. No, there isn't much point to it. But the bottom line is that X input just does not support legacy devices. So people who have old gamepads, they won't work unless you use X input. Or they can run a program sometimes that maps direct input to X input. But it's nicer if you do it nicely for them, right? So there's that. Let's see here. Let's see here. I deleted the min and max Mac. Yes, that's true. I did. I had said that I kind of wanted to. So if you remember, basically in the dead zone processing, I was using I sort of said I wish I should use a min and max here, but I didn't have one yet, and so that was in this code. So right here, I was saying I could use that. I don't think it's relevant anymore because especially if we change to a circular dead zone, then it's not relevant anymore. So I think we don't actually need that to do anymore. But thank you for catching that. That could have been appropriate. We'll get to min and max macros at some point, certainly. Yes. So when you use the 0 controller, why don't you just do star new keyboard controller equals brackets? So the answer is because I don't think that used to work. Let me show you what the person was talking about. They were saying when you do this, can you just do that? And C++11 may allow that. Yeah, it does. But I'm pretty sure that didn't used to work. I'm kind of torn as whether how much of those sorts of newer features we should be using. But I guess if someone was implementing a compiler, this is a pretty easy thing to do, just the fact that that clears something. So I'm okay with that. So yeah, I'm fine with that. That's totally cool. I don't have a problem with that. Yeah, we'll go with that. We'll go with that. I can live with that. I can be happy with that. Let's see. Looks like someone was asking about normalizing to the dead zone to max short thing, which is actually something I just did. So yes, whoever made that suggestion, that is a very good suggestion. That is exactly what I thought should be good. Let's see here. Standard def should include offset of. You could use that to make your assert a little simpler. That's true, but I'd rather just stick with the pointer arithmetic so we don't introduce more overhead there. Maybe, I don't know if we'll use offset of in the future. We might. Basically, there's a macro you can do called offset of. I'll show you the docs for it here, actually. So offset of, which simplifies some of the stuff that I was doing. Where is a good reference? Here it is. So basically, there's a macro called offset of, and what offset does is it takes the name of a type, and then it takes the name of a member inside that type, and it returns the delta between the base of the structure, the start of the structure, and that type. So it's the offset inside the structure. So this code that I had here, right, and I'll just go ahead and do it. I'm fine with using offset of. I don't have a problem with that, I guess. But basically, if I wanted to, I could make this use less, it could be less verbose by basically saying, like, okay, really all we need to know is just the game controller input. Instead of having to give a reference to it, I just want to say that terminator, right, minus the offset of the buttons array there, right? Oops, that's not good. Minus offset of game controller input. There we go. Buttons. That is essentially equivalent to what I had written before. I don't know if that makes sense. I don't really think there's any reason to do it, and since I have to use the other one for array count anyway, although I could, I suppose, write array count in front, I think I'd rather just leave it the way that it was, personally. Let's see. Anything else? Anything else that I missed? So we'll look at the circular dead zone later. So I'm not ignoring that. We will absolutely. I'll check later tonight actually to see if I can find someone who can say definitively what the hardware does, dead zone wise. But let's take a look. So is there anything else? Looks pretty good. I think we've covered just about everything that is relevant to today's code. Yeah. All right. So thank you, everyone, for joining us. Sorry there were so many questions there that it was hard to make sure we got all of them. I think I got all of them related to what we do. And I want to table the circular dead zone thing. It's important because I do want to model the hardware accurately. So it's very important. I don't want you to think we're skipping over it. We will find out whether it's circular or a rectangular dead zone, and we will adjust accordingly. But even if it is circular, I'm afraid I'm going to have to probably table that for another 2 weeks till we can talk about vectors, because you really need Euclidean length to do a circular dead zone. I can't think of any way to do it without that. So we're going to have to get to that point before we can process circular dead zone. But we'll find out which one it is. I will track down someone who knows for sure how these controllers are made internally, find out whether they have circular or rectangular dead zones, and then we will go from there. That said, thank you very much for joining me for another edition of Handmade Hero. I am very pleased with the progress we made today. We have our input layer looking much better than it was before. Probably still some bugs in there because we haven't tested it, and you always have bugs until you test. So we need to do more testing, and we will do more testing. in the future. But for now, I'm pretty happy with how we've got it designed, how we've got it working. I think it's really good, and it's going to continue to get better over time, so that's great. We need to work on our frame timing, so that'll be tomorrow. And then after that, when we get the frame timing done, we're pretty much closed in on just final cleanup stuff, some extra stuff I want to get in there for going forwards with the memory and a couple other things. So we'll have a Thursday, and we'll have stuff to do on Thursday and Friday as well, even if we do finish up frame timing tomorrow. But we are well within reach of closing out the entire platform architecture stuff that we needed to do for our first pass. And I am very excited about that. I'm psyched to get to starting to work on the game next week. The art is looking awesome. Yangshin does amazing art, and I'm really excited to start getting it up on the screen too. So that's going to be awesome. So thank you everyone for joining me and doing another hour of programming. I encourage you to go to handmadehero.org if you hadn't already, where you can go to this news and forums button. It's got like a pretty nice forums on there. People have been posting a lot of great information. There's an episode guide you can use to follow along with the series, and there's annotated notes, and Iker does a bunch of illustrations every week. There's just tons of good stuff on there. Just go explore and have fun with it. It's some crazy web stuff that, I'm not very good at web stuff, so it's a little janky, but it works. So check that out. And of course, if you would like your own copy of the source code to play around with, you can pre-order the game by just clicking on this button. It handles both Stripe and PayPal, so you will get a link, and make sure when you do that, make sure you use a valid email address, because basically it sends you a link in an email that's where you will always go to re-download the source code every night, because I update it every night. So you want to save that link that comes in the email, because that's what allows you to download the source code, and that's also what allows you to download the game and the assets. So save that. Every time we do a major build release, so as the game goes forwards and we start doing milestones, I'll send out an email that has a refresher link in it. But just make sure you save that for now so you can always get the source code. Because I don't know much about Sendal. There probably is a way to kind of just have them resend you your thing, but I just want to make sure people don't miss it. So thank you very much for joining us. Tomorrow will be 8 p.m. Pacific Standard Time again. I hope to see you all here. It's been wonderful coding with you, and it will be. I'm really excited to get the frame loop cleaned up tomorrow, because I think that's going to be a lot of fun too. So hope to see you here tomorrow, and thank you very much for joining me.